Okay. Hi, everybody. A very good afternoon to one and all. Sorry for the last minute postponing the session with 1 hour later. So it was initially planned at 11, and we have just kickstarted at 12 p.m. to 1 p.m. So we have Anandan Suruli here. He's senior software architect at DHL. So today he is going to cover about serverless computing in Kubernetes. And we have planned this as two sessions, as two parts, so that Anandan would establish the basic concepts and a basic setup kind of demo in this session. And we will be having another session which will be dive deep about setting up the about the internals of setting up the Kubernetes cluster and the problems which are being run through in that. All those things would be in the part two. So Another, please take over.
Hi. um, Hi everyone. I am Anandan Sulli. Sorry for my voice. Somehow it's broken. And by the way, Dinesh, I am not a senior software architect in DHL because that's a big role in our company. So I am just a software engineer in DHL IT services, and so yeah, we are doing a lot of stuff in because we have a lot of data centers. So we need to do lots of POCs, and then uh, how can I say it? In DHL, we are running all the applications in the OpenShift. So it's the same as the Kubernetes, but the difference is Kubernetes is open source, right? So our guys need some paid versions, so they have a cost, and then they need a full-time support. They plan to go with the OpenShift. But OpenShift is built on top of Kubernetes. Anyway, if you want to do any customization or if you want to run any own your patch up and everything, still we need to know about Kubernetes. So, well, yeah, and that's about myself. And yeah, and apart from that, I am a full stack developer. Yeah, that's all from my side. Maybe we can go into our session. So the session about purely about serverless computing in Kubernetes. So before I am going further, I will explain you something. How can I say that? So we heard serverless computing in AWS Lambda functions, and then at the same time we heard in Azure and then Google.
Sorry to interrupt. Guys, can someone confirm in the chat whether you are able to hear our voice and see the PPT screen?
Dinesh, can you share the YouTube link
Um,
to this window?
no, it's actually we are on the part of YouTube only. Yeah. Okay. Two people confirmed it. You can go ahead, Anand. Yeah.
Yeah, okay. Actually, we heard the serverless computing in uh, AWS and then Azure and then what is called Google Cloud. So in AWS, they call it Lambda functions. In Azure, it's Azure function. So they call it as Azure function. But still, when we have a legacy application or when we need to go for the containerization, how can I say that? So just assume we have the application. It's built on our .NET C Sharp. So it's just a MVC application, but it's built 10 years before or 8 years before. So I just want to go for the containerization. What we will do, we will write some Docker file and then we'll push the images, and then we'll just deploy to the Azure Container Instance or Azure Container Services or in Azure Kubernetes Services. But whenever it goes for scaling and then still we need to do a lot of manual work for the developers and then architects and who's handling the Kubernetes cluster. So still we need to do a lot of stuff. So those are all, it's quite very, how can I say it, for the developer it's time consuming or yeah, it took definitely a lot of time for deploy to the Kubernetes cluster also, because still it needs to manage in a lot of ways. So there is a that's why in Azure and then GCE or AWS, they came up with uh, serverless computing for the application. So but the thing is, when we are going for the serverless computing, we need to rewrite our source in uh, obviously we need to rewrite our full source code. So that would be definitely for the company side, or our how can I say it, for the developer side, we still need to invest a lot of time and a lot of resources and a lot of cost. So Kubernetes, they come up with the idea for Knative. So yeah, maybe I will reveal it later. Will I will just explain the Kubernetes. Okay, why we need a Kubernetes? So it's very simple. We have a traditional deployment. What we'll do, we have some physical server. It's running in some cloud or in our own data center, but still we need to install our operating system, and then we need to run our application. That is the traditional deployment. But for the virtual deployment, that means when we have a VM in the cloud, it's the same. But the thing is, we have a hypervisor. So how can I say it? In the same physical server, we will run a multiple VMs, and then we will host multiple applications in the virtual machine. But in the container deployment, it's totally different. The thing is, we don't have a hypervisor here, because in how can in a virtualized deployment, we have a ghost OS and then guest OS. Host means, how can I say it? Maybe we are going to create some VM with the help of Oracle VMware. So I have a Windows. On top of that, I will install the Oracle VMware, and then from that I will create a Ubuntu, or again another Windows machines, or how can I say it? CentOS or a Fedora, whatever we want based on our requirement. But the sorry, yeah, that is in the VM. But in the container deployment, we have only Ghost OS, but our container will share the lot of libraries and then etcd and everything to the Ghost OS. So we don't have any guest OS here. The thing is, why we need that? Whenever we deploy the VM, or whenever we creating the VM, something is broken. Whenever we need to recreate the VM, it will took a lot of time whenever spinning the VM, right? So that's why we need a mm, sorry, that's why we need to do something there. So that's why the containers came to the picture. Actually, it's around 2000 or 2004, I think Linux came up with this idea, because before Docker came to the picture, it's already the container environment creation is already there in the Linux. So they took it from there, and then they developed some libraries, and then they publish it. So it's very popular, because in container we will spin up our application, or will spin up our containers within a seconds. That is the uh, beauty of the container. So that's why people move to the container. So okay, but here why we need a Kubernetes? We actually we will spin up a lot of containers, but there is no, how can I say it? There is how we can manage the containers. So that's why Kubernetes came to the picture. It's a portable and then extensible, and it's for open. It's developed by how can I say it? It's not a Google. So actually these ideas came from Cloud Native Foundation, and then Google Cloud acquired the idea, and then they developed a lot. So that's why now Google is on the Kubernetes. uh, and here, right? Uh, so when we have a Kubernetes, we'll manage the container, and then we'll spin up the container, and then we'll okay, I will tell you the some of the great features in the containers. Actually, we'll deploy the container within the second with any of the platform. But why we need a container? We need to manage our DNS, and then we need to manage our if something is broken, we need to again create the container. Those are all we need to care about, right? For the security part, in the security areas. And then apart from that, when we are mapping our application into the some custom domains, maybe we have something like, for us it's a dbdhl.com. So if I want to map some dbdhl.com slash some APIs, so I want to run to map this URL to some of the container, means I need some sources. So that's why Kubernetes came to the picture, because it's for the orchestration management. So when we have a multiple VMs. How can I say it? Actually, in the Kubernetes, right, a minimum will have a three, how can I say it, two master nodes, and then four cluster node. That's the case for how can I say it? Maybe it's quite different one. Okay, in the Kubernetes, I don't actually here I am not going to explain about the Kubernetes installation and the Kubernetes overall, because we already Karthi is already did it in the lots of sessions. So just I am going to refresh those areas. If you guys want to refresh full Kubernetes, please reply it in chat. Hi, anyone, please update it if you then okay, then I will go from Dinesh.
Anandan, can you repeat the question? Maybe.
Okay, actually here, right, I need to take a lot about Kubernetes, or can I directly go to the advanced topic of Knative? Because yeah, already got it, took the session about Kubernetes. If you guys want, I can. Otherwise, we can directly go to the Knative. That's why I'm asking the question.
Okay, I think it's good to go give some introduction for 5 minutes or so, just to set up the ground up.
Okay, that's nice, Dinesh. Okay, in Kubernetes, right, it's orchestration management. So when we have a multiple VMs or a multiple physical servers, we need to spin up the, how can I say that? Actually, in container, right, when we have a Docker, we just deploy to the one physical server or VM. That's not the case in when we are going for the cloud computing, or when we are going to have our services run by, how can I say it? Uh, Disaster recovery, or something called auto scaling, means definitely we need a multiple VMs. So when we are hosting our application, we have around 8 or 10 VMs. So the minimum requirement in the production for the Kubernetes, two master nodes, and then eight cluster nodes for the production. This is the minimum requirement in the production, but you can try with one master node, and then how can I say it? Two cluster nodes. So this is also fine. Why? Because the master, I don't have any, how can I say? Maybe I will say it in my thoughts, but I don't have any documentation about the Kubernetes, because here I have not took anything. In my presentation, there is nothing about the Kubernetes. So because it is a big topic, so I will explain. So the master is the main brain for the Kubernetes. The master node is going to handle the service deployment, and then service discovery, and then what is called mm, splitting the traffic, and everything it's going to handle by the master nodes, because in master node only we have a database called etcd. So whatever we are doing, or whatever we are creating the service, it will store in the master node only. So why we needed two master node for the production? If something went for the, because definitely when we are going to the production, obviously we need a two master node, because some VM is broken. Definitely another master node needs to be there for the disaster recovery, or something is broken, we need to care about the whole cluster, right? So that's why we need at least minimum two master node VMs, and then eight uh, cluster nodes. So we have eight cluster nodes, but we need to spin the, we need to create our application into the cluster nodes or cluster VM. So in Kubernetes term, it's a node. So sorry for confusing the VM and uh, cluster node and then master node, because at the end it's a VM, but in a Kubernetes term they called it in a different way, because that's why they call it. because in VM means it's common, same, right? So they want to separate the master and then service node. So in whenever we are installing our Kubernetes or whenever we spin up our application, maybe Dinesh said we want to create application for a Hello World C Sharp. So it needs to be go to the production. So we will create some service in Kubernetes, and then it will say it needs to be run on any of the cluster nodes. But that is case, you can directly mention I need to run this application in the VM2 or VM3. But if you are not mentioning, it will just check the how much resources it's already, how much resources is already utilized. So based on that, it will deploy to the VMs. Maybe someone has asked a question: is it mandatory to 10 VM 2 masters and working node to set up and to set up? Uh, Hi Rajesh. Yeah, it is mandatory for the production, but how can I say? You can still go with the one master three with the help of three VMs, because one master node and then two working nodes. But how can I say? It will work, but that's not the recommended choice from the Kubernetes or Google. And maybe okay, in the Kubernetes, you can how can I say? I'll say here why we need a Kubernetes. We need a load balancing, and then we need a storage orchestration, and automatic rollout and the rollbacks. Okay, what is about automated rollouts and then rollbacks? We can have a multiple versions running in the our application deployment version, maybe 5 or 20 or 30, based on your size. You can define how much versions you need to handle, because something went wrong, you need to again roll back, right? So that's why we have a version handler in it's not called version handler. How can I say it? In the build in Kubernetes build, you have a version history, so from there you can again redeploy from the whatever the version you want. And apart from that, the main how can I say it, the beauty of the Kubernetes, it's a self healing. Something went to the container, something went wrong to the container, it will kill that, it will terminate that container, and then again it will create the new one. So that is the beauty of the container. But here is the how can I say it, beauty of the case, because we have rollouts for instance, we are running instance for 3 or 4. But if something went broken, something went wrong, it will kill one, it will terminate the container, and then if automatically it will recreate the another one. Okay. Oh, why we need it? Because suppose in our how can I say, traditional deployment, uh, in our traditional deployment, we can say it like something when broken, our application or our, yeah, our software or our application is not responding to us, right? That's why we need uh, then we need to again some of the tech support guys will create a ticket, then again we need to redeploy it. So it's some complex approach, and then it will quite damage our customer name or our client name or our maybe our product names, right? So that's why self healing is very important. How the self healing is work? It's very simple. Kubernetes will check, Kubernetes will do some curl or some rest, how can I say, it's an internal process, right? So do some request to the container, it will not respond properly within 2 to 3 minutes. By default it will terminate. So that is the beauty of the self healing. And then we have secret and configuration management in Kubernetes also. In Azure we have something called Azure Vault, right? So Azure Key Vault, sorry. So same thing, we can store the secrets, and then we'll store like some configuration. And if you want lots of storage, or maybe here, how can I say it? Okay, you have a NAS, it will add to the Kubernetes, and then yeah, for the some of the application, I need some memory, not a memory, a storage for like 20 or 30 GB of SSD or SDD. So based on that, I can claim from the Kubernetes, because those are all handled by the storage orchestration. If you want to set it up, maybe you can set it up from the Azure cloud itself, because some of the storage you want, you can have those storages also. uh, and if you want, you can claim it. uh, if you want to increase in automatic also, that's also possible. Sorry. And yeah, that's all about the Kubernetes. If anyone want to know more, please comment in the comment sections, because otherwise I will go from my slides. Hi Dinesh, this is fine.
Yes, Sanathan, this is fine. You can proceed.
Yeah, okay. Okay. At last we came to the our main picture of the session. So serverless computing. In theoretical way, serverless computing is a cloud computing model which aims to abstract the server management and low-level infrastructure decisions away from the developers. So the thing is, in this model, allocation of resources is managed by the cloud provider instead of application architect. So which can bring some serious benefits. In other words, serverless is aimed to do exactly what it sounds like. Allow applications to be developed without concerns for implementing, tweaking, and scaling server. Okay. Just a minute. Sorry. Actually, here, right? Okay. You know what? Why we need a serverless computing? It's very simple. Because when we have our resources, right? So it will scale 0 to n whenever the service is required. It will by. I will talk about Azure functions. In Azure functions, we have a HTTP triggered function, right? So for that, uh, in Azure HTTP trigger function, whenever we trigger some HTTP URL, it will deploy our function, and then it will serve our request. So that is the beauty. So and apart from that, if you don't have any request, it will go to the zero compute resource. So that means they don't charge for when we don't have any request from the users, the application don't exist in the server. That is the beauty of serverless computing. And apart from that, but in Azure function, we need to write lots of code. We need to if you have already application, when you are writing new application, I will say it's really good choice to go with Azure functions. But when we are creating when we are migrating our existing application or a legacy application, it's actually tedious approach to go with the container also. But at the same time, if I want to go to the serverless computing, it is not possible, because I need to rewrite my all the codes and then everything, right? Because I know Karthi took a lot about Azure functions, and then Dinesh and Rajesh, those people spoke about lot about serverless computing in Azure functions. And because when we go, definitely it will save the lots of costs. But at the same time, I need to achieve the serverless computing without migrating my application. That's what I'm going to take a class about. How it is possible? It's possible. I I'll go to the next slide. Maybe from there you will get it. Okay. Kubernetes is the ideas came from the CNF, the Cloud Native Foundation. From there, we have one more idea and then implementation. It came for the Google Cloud. So it's a Knative. So it's actually extends to how can I say it? wherever the Kubernetes cluster are running, not only in Azure, but Google Cloud or your own data center or AWS or DigitalOcean, any of the cloud computing or any of your cluster is running, we can able to achieve a serverless computing with the help of Knative. Okay. What is Knative? Knative is just a middleware components that is essential to build modern source-centric and container-based application that can run anywhere on-premise, in the cloud, or even in the third-party data center. Actually, we are running in the third-party data, not a third-party, our own data center, because we have around 7 data centers around the world. So we are in Knative. We have two components. Sorry, in the build they took it some 3 components. Maybe I will explain it later. So it's a serving and then eventing and then build. Yeah, in Azure functions also we have the same kind, right? So when we have a Azure HTTP triggered function, it will serve the request based on the HTTP trigger event. So it's a event driven computing model. So but here it's quite different because we have a serving and then eventing. The eventing is exactly same to the Azure. How can I say it? When we are running some whenever we'll receive some request to the blob storage or some database, yeah, maybe Cosmos DB, so it will trigger some events, right? The same was in eventing. Okay, but today we are going to see about the only serving. Okay, what is Knative serving? It's rapid deployment and auto scaling of serverless containers. Okay, and here is the main thing. When the application is state oriented, don't go with Knative or Kubernetes. Kubernetes also, because in when you are deploy your application with stateless, right? So how can I say it? Maybe when your application is coupled with a loosely coupled application, definitely go with Kubernetes and then Knative or whatever, right? So when our tightly coupled application like we have a session storage and then we have everything in the application itself, don't go with those things because it will whatever went wrong, it will spin, it will terminate our application and then it will recreate our application. So it's like a self-healing, right? Yeah, definitely it will be helpful, but when we have the legacy application, most of the application is running out how can I say it? Mm, tightly coupled application, right? So don't go with, just try to make sure you have some Redis session and Redis cache for session and some of the application caches, and then if you manage to store some of sessions into the Redis cache, you can go with the traditional our legacy application into the container also. It's not a big deal. Sorry. Okay, and in serving, right? So it's a rapid deployment and auto scaling of serverless containers. So here is the beauty in the Knative. Actually, Knative goes 0 to n auto scaling. So before that, at least we need to run our container at least minimum one pod. In Kubernetes, we'll call it as pods, right? So we need to run a minimum one pod for single application. That is the recommend. That is the that's how it works. Otherwise, it will not work because it will not serve our request, right? But in Knative, it goes to 0 also, 0 to n. That is the beauty of the Knative. Okay. And okay, what is Knative serving? Knative serving allows for a rapid deployment and auto scaling of serverless containers. You just need to specify what container to deploy, and Knative takes care of creating the container and manage the root traffic. Once serverless container deployed to Knative service, features like automatic scaling and revision for each configuration change, traffic splitting between different revisions and more will be in a place. Yeah, that's nice. It for us definitely it would be nice, right? I think if anyone have a theoretical doubts, please ask me. Otherwise, we'll go to. I will show the demonstration about how Knative is works, because I will share some URL. You guys can also try it. Not try it. You guys can check it. The actual response. Anyone have a doubt about Knative? It's just a middleware. In maybe I will just demonstrate briefly. How can I say? In Kubernetes, right? There is a lot of uh, topics we need to know, and a lot of things we need to do. There is one thing is called as CRD, custom resource definition. It's about we can how can I say it? We will create our own CRD also, or you can write your own CRD with some Go language or Rust. That's also possible. But here, right? So we are going to, in our term, it's just about some middleware components. We will add some components to the Kubernetes. It will take care about our services and then everything. Maybe Dinesh, this is fine, or we can go for the demo,
We can go for the demo, Anand.
because I didn't get any response from
Yeah,
people.
we can go for the demo.
Yeah, okay. Mm.
I have shared your browser, Microsoft Azure portal, Anand.
Yeah,
Okay.
okay. I will show some demo to how to create a Azure Kubernetes cluster in Azure Cloud. So please go to the create resource, and then from here, I just type Kubernetes. So we'll get Kubernetes services. Here we'll create the Kubernetes services. And before, if maybe we'll make some interactive session about this. If anyone want to try it in their own machine also, please let me know in the comment section, and then I will guide you. Dinesh, you want to try it on your Azure Cloud?
No, I think you can go ahead, Anandan. Just explaining the procedure. So
Okay.
if people want, they can watch over the video and they can try on it.
Okay. So I will upload some contents to my GitHub also, and they can get it from there also. The thing is, here we need to create some resource group. So first of all, when we have a trial version in Azure Cloud, it won't work because the cost is for this VMs are too high. So definitely they need a pay as you go service. And we need to enter our cluster name, and I have just tried in the region for in Azure East US. I have not tried on any other zones or any other things. And for the Knative, right, for the latest version, it's 20 version 20.0. But the thing is, sorry, 0.20. It is required a minimum. How can I say it? The minimum required version is 1.17 for the Kubernetes cluster version. But here we can go with the latest version. By default, Azure only supports not support. It recommend the 1.18.14 because it's a LTS version, maybe that's why. But the latest version is 1.19.6 in Azure, but actually I think it went to 1.20 point something for the latest version. But you can select the 1.19.6, and here maybe Rajesh asked, right, why we need 10 VMs, right? So I am just going to choose the general purpose TS2v2 because it needs to somehow some, how can I say it, the minimum requirement for testing this feature, uh, uh, TS2-v2 in the model, the VM size. It's quite costly also, around monthly 7,000, but it will come around, how can I say it, when you're trying this per day, it will at least charge about 1,000 or to the 1,000 rupees, I think so. But because I am already chosen here, node count you can, maybe if you want in the production you can make it 10, but you can go with 3 itself. So just create a Kubernetes cluster. Validation is failed because I have not provided the information. So we I just entered the cluster name Knative cluster test and review and create. I don't know why. Maybe I just refresh the page. Just create. Kubernetes version is 1.19.6. Okay, sorry. I already created the cluster. That's why it's showing the error, because for my quota for this selected subscription model, somehow I limited. So that's why. So after this, just review and then create, review plus create. It will So the information about the cluster name and the details, and once we click the create, and it will create the cluster, but it will take around 10 or at least 10 minutes. And after that, here I already have created a Knative cluster. I can go with this. Actually, it doesn't have anything, or how can I say it? It doesn't have a lot of information about nothing. It's just a Kubernetes cluster created from the help of Azure. But if you are installing in our own data center, definitely, how can I say it? This would be a very tough process, because it will take a lot of time and a lot of learning curve, a lot of things. So Azure made our life easier for creating the Kubernetes cluster in a Azure Kubernetes service. So I just created the cluster. So from here, we'll go from the terminal. Okay, and on the thing is, in when we are go with the Kubernetes, right, we have the how can I say it? UI portal also, but people are all the tutorials are prefer to use the uh, terminal itself. So here, right, so maybe I will show something. See here, my resource group of this Kubernetes cluster is Knative group, and then my Kubernetes name is sorry, my cluster name is Knative cluster. So these are all record information, and then the cluster is deployed in the region of East US. So the location is East US. So just a moment. Actually, I need to connect my kubectl. Okay, in Kubernetes, we have a kubectl commands for getting information about the Kubernetes clusters and the nodes and then services, and then we will have some configuration like secrets, and then we'll have some config map, and then apart from that, whatever it is called, we can there is a deployment configuration and then build configuration. Whatever we want, we can get it from the kubectl commands. So if you guys want to know about kubectl, please learn from kubectl help, because from here we'll get a lot about the kubectl. So I am going to check about my notes here. So already my kubectl command is mapped to the my Azure server, because otherwise, maybe I'll tell you something. We need to run some of the configuration setting in here. Maybe I will show you. Okay, in Azure command line, Azure CLI, right? So we can use it in Cloud Shell, in Microsoft Azure Cloud Shell. By default, it's already installed, so we don't need to install Azure CLI, because I am not trying in my local machine. I am trying in the Azure Cloud itself. That's why I am using the Cloud Shell, not my own machine. So here, uh, when we are running these commands, because it will get credential about uh, Azure Kubernetes clusters credential, and then it will map to my local kubectl commands. By default, you will have a kubectl, but you cannot able to access the actual kubectl actual Kubernetes cluster. So people need, or we need to run this command in our machine. So this is the command. So I will after the session I will host all the commands in my GitHub, and then Dinesh will share it in our meetup group, and then you will get it from there. So I already run these commands when we are when I tried this. So now I just need, okay, here is a kubectl is I map to my local kubectl into the Azure Kubernetes service with the help of Azure CLI. And apart from that, when we are installing a Knative, right? So installing Knative is a really very complicated process. It will take a lot of time, and then definitely we need a, a lot of a learning curve also. But once you set it up, it will make our life very easy, and then happy also. Uh, because I am already installed the Knative, because it will took around 2 to 3 hours. If we already know about all the concept about Kubernetes, and then it will easy. Otherwise definitely it will take a lot of time. And yeah, uh, I already the Kubernetes Knative setup for the Kubernetes cluster I already posted in my GitHub repository. So I will share the repo. You can get it from there, because it's really very. It will took a lot of time. Otherwise, I don't think I can go. Definitely will not finish this session. So we'll directly go with our Knative sessions. So, and apart from that, I will tell something about in Kubernetes. We'll have a namespace. Namespace is called in term our projects. Maybe we will have multiple projects. Not multiple. How can I say it? Maybe if you are working on a service oriented organization, so we'll have some domains, or not, it is called domain, maybe accounts, right? So based on that account we'll have a multiple projects. So every project we need to deploy it separate, and then we need to manage our configurations, right? So that's why in so that's the same case here also. You have a namespace related to project. So I'm just going to get my what are the namespaces available. So I already installed the Knative, uh, and then it's installed in the name of Knative serving. So I'm just going to get my what are the pods is running in my Knative. Sorry, kubectl get pods. When you are running the kubectl get pods, by default it will get the namespace from default, because we have a default is given by the Kubernetes cluster. So I'm going to take, if I need to mention the namespace, you can type namespace knative hyphen serving. I have some controller, and then ISTO for our ISTO ingress controller, and the networking controller, some webhook. Okay, basically it's run from the webhook itself. When we are receiving a request to our application, it will yeah, that's all. And how can I say that? Whenever you are requesting to application, it will receive a HTTP request, and then from that it will from the webhook will tell to create the container, and then control ingress control nginx ingress control will take over about the creating the control, and then route the traffic to the actual container. So that is the beauty of the Knative. And apart from that, so if I have a in Kubernetes, we can check we'll have any services are running. Yes, I have a lots of services are running. Hello world, and then hello world private, and then hello world go, and then hello world. So I already tested some of the services, so that's why it's showing. Maybe I will delete all the services. So I just deleted the hello world serving, and then so now if we check our services, I do not have any services running in this in my Kubernetes cluster. So before we need to go further, we need to get the public IP of mm, Kubernetes cluster. So we have some commands. So we can, if you put it there, you can get it. So maybe just a moment. So I have Nginx ingress controller for reroute the traffic. So I have two parts running on the Nginx routes, and then okay, maybe I will get my public IP of this is just 1 minute. Okay. I will get the IP of my So actually, public IP is mapped to the ingress controller. So get services. This is my external IP 40.88.253.250. This is my IP. So whenever we create this request, right? Maybe I'll give out some little difficult process about the what is it called something. Mm, it's called about our okay. Whenever I will create the service or to the Knative serving, so it will map to this IP because I just added some DNS CNAME to the xip.io because whenever we create the URL, it will reroute to this application. Okay, and after that, so now we will deploy our application. So here I have a hello world serving YAML file. So it will just have the hello world go. It's in Kubernetes the term called the in kind means we can mention config map. We can mention the we can create a config map, and then we can create a deployment configuration, and then build configuration, and secrets, and if you want namespace, and then if you want to in the pod and whatever, we can mention it in the kind. So this YAML is about creating a service. So here you just to see the API version is serving knative.dev dev hyphen v1 because I am just mapping this API version to the knative serving, and apart from that, this is just a service just to have the URL, and apart from that, it doesn't have anything. And here it will, and in a spec in the template inside the container, it just have the it just take the hello world go program from the Google uh, registry. The Docker will have we have a Docker up, right? So they have a open source registry that's called GCRIO. It's a Google Cloud registry for the images. So we are taking images from there, and I will ask some suggestion to our participant. I can go with C# example, or I can go with Go example. It's based on your choice only. Maybe please give some comments in the comment sections. Dinesh, what do you think? We can go with C# or we can go with Go long?
C sharp would be fine.
Yeah, okay.
Unless if anybody else have, okay, C sharp is the audience C sharp.
Okay. Then that case, I have another YAML file. Our how can I say it? Our application name is Hello World. So the service name is Hello World. So I have some C# repo. Maybe if someone have the any other repo, if I want to try it, you guys are ping in the comment section. I will take it from there, and then I will deploy to the Knative serving, and then I will show you how it works. This is a C# only. Maybe I will push this code into the. Anyone have any Docker image in your repo? It's a public in Docker Hub. I will try it, that also. Dinesh, do you have any hello world application or a simple application. It's in a demo application running in
No,
your
not in C
application.
sharp. Maybe you can try your own, or
Yeah, maybe I will check. I don't have anything. Actually, that service has already Docker image, but that's from how can I say? Okay, I already have a one hello world application. It's built on C sharp. Sorry guys, I don't know the actual Docker Hub registry URL. That's why I'm taking the URL here. And this hello world C sharp application also, it's already in my GitHub. But actually, I want to try to test it some of the participant Docker image. So anyhow, it's fine. Okay, here I'm just going to edit the YAML file, and then I'm going to, okay, and that's the case. It's very easy, I think. So I'm taking the hello world, and so I don't know, that image was built before 6 months, so I just put the latest version. So in our service file, so in docker.io Anandan side, I just mentioned my image, and in services also. Before going to check kubectl get, so I don't have any parts already running in my machine. So whenever we are doing deployment, we need to create a build config and then deployment config also, but here that's not the case. In deployment config, the see kubectl get actually I don't have any resource for this. Maybe I can try with Knative serving also. So I have some deployment config for the nginx ingress controllers and then activator and then controller about the, it's about totally about the Knative installations. So I have for I have it, but I don't have anything for the hello world application. That's why I showed it here. But when I create a service, right, cube, so we have a file called serving service v2.yaml. Okay, so we can directly create it from the file itself with the help of kubectl command. Kubectl create -f, file name is serving v2.yaml. So the service is created. We can check the service now. Kubectl get svc sorry. So maybe what is our service name? Hello world, I think. Just a moment. At serving. Oh, okay. Our service name is hello world. So kubectl get svc. Sorry, it's sorry about some confusion. So it's about ksvc. I'm just checking the different one. So here I have a URL called, so I can directly hit the URL for this. So before I'm going, actually our application is deployed and I don't have any pods running in my machine. I'm not going to test it in my machine. I am going to share the URL. You guys can check it. It's working or not, because based on the request, right? So I don't know where to put it on the comment section. Can I comment it, Dinesh?
Yes, you can comment on the right side. A chat window is there within the
Yeah.
StreamYard itself.
In actually, it's showing only in the private chat. So if I send it, it will go there.
Okay, let me repost it there.
Okay. because I want to show there is no pods currently running, right? Okay, maybe you post it, right? So I am just going to watch the kubectl get pods. Okay, please try anyone hitting that URL.
Right now, it is not listening. I mean, it shows page can't be found.
Okay, I don't know about my YAML file. Maybe we'll try something. I'll create another service. Here, right? kubectl get or create -f lower serving.yaml. So I created one more service. So actually it's deploying the pods now, and world-go. So I am getting the URL for the Go application. Sorry guys, maybe I will retry with the C# application. Don't worry, but this is for just.
And Anandan, can you have your font size bigger? It is not visible.
Really? Okay, just a moment.
And also a time check, Anandan. So
Yeah, that's all. We'll finish it. No worries.
okay. So what would you cover in the next session? Also, just let the people know.
Yeah. Okay. Is this fine now?
Yes, better.
Okay. Before I am going to give the URL. So actually, there is a pod is running. At the same time, there is a no request get to the service, the hello world service. That's why it's terminating. So now it's the time I will share the URL to you guys. You guys test. You guys give the request to the application. Maybe I will share to Dinesh. Dinesh, you can put it in the portal. And so as of now, it's terminating. If someone is giving the how can I say it, a request, it will create the pod and then it will serve the. See, I think I don't know who's given the request, so it will create the whenever the request is came to the application, it will create the pod and then it will serve the request. So if by default it's around 90 seconds, not 5 minutes. By default, the terminating part I said it's a 5 minutes in the configuration, but still you can edit. Yeah, whatever the maximum is 5 minutes. If any request don't get to the your application, you don't need to consume the memory or consume the resource in the Kubernetes cluster. So yeah, this is the beauty. I know people actually people knows how the Azure functions works, right? So the concept is came from the Knative. Microsoft also they are contributing a lot into the Knative repository. Uh, Maybe I will have what is called C# also. Guys, have any questions about Knative serving? Please comment in the section, and I will clear it. And at the same time, I will just edit my another Docker file. That's also built in the code was built in C#. Just changing the username. The version is v1. Any comments? Anyone have any doubts? Please ask me in the comment section. I will explain it. So it's better I can delete and then recreate. Delete -f. So the now Hello World application also running. So I'll give the request. Yeah, it's showing now, but it's built it in the C#. Maybe you guys can test the first URL. That is also working fine as of now. So I will check it and get kubectl get pods. So now Hello World deployment is running because there is no request for the Hello World Go application, so it's terminated. So whenever we'll receive the request, it will create the pod and then it will serve our request. Otherwise, it will terminate the pod and then it will save the computing cost and then resource cost also. Yeah, that's all from the Knative serving. So next session, it's about Knative eventing. So we'll have something like we'll have some subscribe and then pops up concept. So we'll send some message and then we'll receive, and based on that, whenever the request is received to the application, based on that it will create the pods, and we'll see a lot about Knative eventing. Dinesh,
Yes, Another.
I think yeah, that's all, and then we'll share the URL also. Maybe Dinesh, you can test the Hello World application. It's built in the C#.
Yeah, I just did it, and then it was working now.
Okay.
Yeah. So thanks a lot, Anandan, for your wonderful session. And so
Yeah.
keep just keep watching the meetup group. We'll create one more meetup, which would be the deep dive session for the advanced that, and that will be completely of a demo kind of thing.
Yeah. Okay.
So thanks a lot. Thank you, Anandan.
Yeah. Okay. Thanks, Dinesh. But this goes. It went good because I don't know. I took it in the right way.
Yeah,
That's why I'm asking.
yeah, it went good. Let's discuss.
Yeah.
Okay,
Because
let me broadcast.
yeah. Sure.